Så da sier vi velkommen
Great.
til Susanna Lopez Aparicio fra NILU, som også har kreditert forrige taler Henrik Ryte på denne presentasjonen. Så vet jeg at du noen ganger prater på engelsk og noen ganger på norsk. Du kan velge selv.
Ja, jeg kommer til å gjøre det på engelsk, men vi kan diskutere på norsk etterpå, så jeg håper dere hadde ikke meg for å være siste og på engelsk, men det blir
Det
fortere.
går veldig fint, så det har gått bra før. Så vær så god.
Greit,
Den er din.
tusen takk. Okay, let's not take too much of your time. I hope I'm going to present a new model, quite similar process-wise to NERF that has been presented before. It's a model financed by the Miljödirektoratet as a first step to get high-resolution emissions from machinery, in this case, machinery used in construction site. So a little bit of, I'm finding my last, yeah. A little bit of motivation first. We know that in cities, we have worked very intensively in residential emission from the residential sector and emission from the road sector. But we know that non-road mobile machinery associated to building and construction has a very intensive activity as well. So they may be a significant source of air pollutant and greenhouse gases. However, there is very little knowledge concerning their emissions. The biggest challenge, I must say, with the construction activity is the large variability. For example, using NERF that we saw before, we have the road network that, okay, it changed a little bit, but not so much. But in the case of building and construction, they change in a space and time from one year to another. Construction work change as well. But also the type of construction we have, from small houses that are being built to big construction project. Within each construction project, we have different phases that also it has different activities and will influence emissions in a different way. The terrain is one of the variables that affect emissions because determine the type of machines that we have to use, and the meteorology, as we know, is quite important, especially in the case of non-exhaust emissions. So if we go to what we have available nowadays, in Norway, emissions are available, are classified as motorized equipment. And they are well characterized at national level because the activity data that is used is the tax-free diesel that is well accounted for. However, motorized equipment includes non-road mobile machinery in industry and construction, but also machinery that is used in commercial and institutional sector, household and agriculture, for example, the tractors. So the split between these subsectors is quite uncertain. And then when we need data at high resolution, for example, municipality, because the cities need to see their state regarding their targets to reduce emission, is quite even more uncertain. So the aim that we had at the beginning was to develop a model to estimate the emission from non-road mobile machinery in construction based on bottom-up principle, what means from the construction site up to municipality and national level, and at the same time that allow us to develop long time series of emission of both air pollutant and greenhouse gases. So the process that we designed was first to identify the location of all building and construction activity, both in space and time. From there, allocate the energy demand for the machinery to finalize with the estimate of emissions. As we saw before in NERF, we like to work with a lot of data, combining different data sets. And in order to achieve all this step in the entire process, there has been a lot of data processing and basic data searching as well, that is very demanding. So I will not go in detail now in all the input data because it comes later on. For example, when we talk about the location of building and construction activity, the where happened this activity, we have worked with the building and construction permits in Norway, the entire data set that we call it the matrikkelen. So we have the data from 2010 to 2020, in where we have information on building type and utility area. The construction permits are split if we are talking about building construction or demolition, and at the same time, which type of building is, for example, apartment building, a school, or detached houses. I must say that to reach this database and to understand it, that we have to thank Trondheim Kommune. There was a person there that was helping us very much to get to understand that this was the database that we needed. At the same time, we combine this information with meteorological data, specifically daily temperature and precipitation for each point in when we have construction permit, and also soil type. The soil type is quite important for two parts. One, because we establish ground conditions, simple or difficult. As you can imagine, if it's simple, the amount of machinery needed is different than if it's a very difficult ground condition, but also the silt content, the type of material, this will determine the non-exhaust emissions. So this sounds very simple, but has required a lot of data processing to reach what we have now, that is the entire Norway, all this construction permit localized on a space with all this information also identify for that specific point. So now we know where it happened, but this cover 10 years. We need to know when it happened. The construction permit is not always so easy to use. Sometimes we have the start and the end date that is well defined. Sometimes we have only the start or the ending. And sometimes we have a start or end, but it's not very well constrained. So we need to identify the construction permit when it happens. Sometimes it's within 1 year, but sometimes covers several years. But also we need to identify the different phases, the different phases within construction. So for this, we use information based on a report that use information on real construction project. So what we did for each singular construction permit, we apply a parameterization that assume an average of 15% of the initial time is for administration, 5% for excavation, and then it comes foundation, activities over the foundation, and the finalization of the building. So this allows us to establish 3 different phases: groundwork, heating, and the building work, in where we associate also different machines active during these phases. That is the large machines, the LPG heaters or diesel generators, and the small machines. So applying all this time parameterization allow us to see, for example, here we can see Oslo and the surrounded municipalities. This is the year 2020, and we see construction activity expressed in square meters. So the bigger the square, the biggest is the construction activity. So we can identify the most important development work that has been going on in Oslo, but also in Lorenskog that has been going through intensive construction activity. But also allow us to observe over time, since we have 2010 to 2020, how the building area has been active. What we have done here is to compare with SSB data. SSB report building construction area if it has started on a specific year or if it has been completed in a specific year. So we individualize this from our data set, also projects that start and finalize in those years to compare and see how some kind of validation. We see that is approximately consistent. There are some years that show some discrepancies that are not so easy to explain. But what is important to bear in mind is that construction activity sometimes takes several years. So what is active is what is represented here with the green line. So approximately, between 22 and 25 million square meters has been active as construction in Norway. So we have now the 3 different phases, and we need to allocate an energy demand. What we did was to allocate energy demand established by the Norske Veritas in 2018. And in the case of groundwork, we distinguish between simple and difficult conditions based on the data on soil. As you can see, they suggest different values. In the case of heating, we also use the Norske Veritas, but at the same time, we distribute in time based on the heating degree day. So heating will be active during the winter months and autumn, and we don't have heating activity during summer. And then the building work is the one that we allocate the lowest energy demand, and it's different if we are talking about a big building block or it's a house. So a little bit of a summary. We have now Norway. We use the grid, the SSB 250 meters grid. We know the activity in square meters. We have now the grid in kilowatts hour and split in 3 different phases. But what we want to have is emissions. As in each phase, we allocate different type of machinery being active. What we need to do now is to define emission factor for this type of machineries. So what we did was to define specific dynamic emission factors for M-site. We use as basics the emission factors suggested by the European Environmental Agency, in where we have different technology class called stage, is the equivalent to Euro classes in road transport, and different engine power. We need to define a fleet composition for Norway that also change over time. We were quite lucky to get collaboration with Cramo. They shared their database concerning their fleet, their fleet machinery, let's call it. And here, this is the example of diesel. What we did was to consider the Cramo fleet composition representative for Norway, and then we went backwards, assuming an introduction, a continuous introduction of new technologies. So we can see here how the different stage, the oldest are being disappearing, and the new stage, more modern, are appearing and becoming more abundant. But as emission factor per technology also depend enormously on the type of machine, we have to use the relative machine population in Europe per power class to get at the end these emission factors. And then we got to the non-exhaust emissions. This is a quite challenging work, I must say. We use the basic approach suggested by the European Environmental Agency, in where emissions, non-exhaust emissions, depend on the emission factor, the area, the duration, the control emission technique that they apply, permeation evaporation index, and the soil content depend very much on the type of material. However, we are uncertain about this very simplistic method, which process in reality represent, and this is not explained anywhere. For example, in a construction site, we have non-exhaust associated with the groundwork, with the movement of material, with material that gets stuck into the tires, but also with the movement both of machinery, but also of heavy-duty vehicles that get in and out construction site. So we are not very sure which process here is included, but also which fraction represent PM10 or even coarser. So with these uncertainties, we work with this method. And the first thing that we did was to modify the permeation evaporation index that depend on precipitation and temperature, because it's expressed on a monthly basis, and we need to work on a daily basis. So we use a permeation evaporation index suggested by the same author, and in this case depend only on temperature and solar radiation. In order to account for the moisture of the soil, we develop a dust emission potential based on solar radiation, temperature, precipitation, so that can describe the changes in the surface moisture. Here is, we can see how will be on average for Norway, represented in black, and then for different regions depending on their meteorological conditions. So as we can see, the non-exhaust emissions are especially important in spring, summer, during the dry periods. Emission factors we use suggested by the European Environmental Agency, and they are different depending on the type of building, but as this information is in matriculum, it's not a problem to be applied. If we go a little bit to result, here we can see for the entire Norway, the PM10 is dominated by the non-exhaust emissions, even though we suspect that we are underestimating because we don't represent all the processes. And PM2.5 and NOx decrease over time and very much associated with the introduction of new technologies. If we compare, for example, Norway NOx emissions with those officially reported at national level, we can see that we have important differences. For example, here you can see M-side as a line and then as columns, you can see officially reported. So we have, especially on early years, much higher emissions than those reported in Norway. As we are treating only building construction, we are missing important activities such as road construction or other type of project. The most logical reason is that emission factors is behind this difference. So what we did was first to compare M-side emission factor with SSB emission factor for official reporting. Here in gray, you see M-side if there are large, small machines or diesel generators, and the emission factors are quite low in SSB or quite high in M-side. The reason for this difference is not easy, as SSB does not explain in detail how these emission factors are weighted and estimated. We compare as well with emission factor used by Miljödirektoratet in the assessment of external cost of machinery used in construction. And in this case, our emission factors are quite similar. Here we have the emission factor used by Miljödirektoratet with 3 different stages, 3, 4, or 5, and depending on the power of the machine. I must say that based on Cramo database, approximately between 60 and 70% of the machines that we have are stage 3, just for indication. If we look at CO2, building and construction activity has been relatively stable until 2020. Here we do not see the important decrease that we saw for NOx emissions, and it's because CO2 does not depend so strongly on technology as air pollutants. And this is the reason that we don't observe this important decrease. Fuel-wise, as we know, diesel is the mostly used fuel, followed by LPG in the case of heaters. So diesel is the main fuel and the main responsible of emissions. If we go at communal level, one of the things that we did was to compare M-side with the previous CO2 reported per comuna in the Klimatregnskap published by Miljödirektoratet. I must say that this is based on the methodology previous to 2022, because in 2022 this methodology has changed. And many years back, we suspected that emission from machinery in the Klimatregnskap were overestimated in some municipalities, especially big municipalities with a lot of business going on or big population density, like, for example, Oslo. When we compare M-side with the Klimatregnskap CO2 emission for Oslo, we see that we have important differences. In our case, show that is much lower. When you overallocate emissions in a municipality because of the proxies that you use, then you have to underestimate in another one, obviously. And this is what we saw, for example, for Lørenskog. In the Klimatregnskap, emissions were relatively low, but M-side show much higher values that correlate with the intensive construction activity that the municipality has been going on in the last years. And just to finalize, I must say that this is a first step. There is many aspects that are not considered, and not because we didn't want it, it's because it's not easy to get the needed input data. And here we need to emphasize that we need to include the construction of infrastructures other than buildings, for example, road construction, biofuels. Biofuels is quite important in some municipalities, especially those with procurements in place for the use of biofuels. This will have an effect on CO2, but much lower on air pollutant. The use of electric machinery has increased very much in the last year, especially in some municipalities, so it needs to be considered. And also alternative energy sources, for example, in the heating phase. part of the heating phase in the construction can run on electricity. And finally, and not less important, the non-exhaust emissions need to be further evaluated, and probably with other methods than modeling, because there are different processes that influence emission, but also that can affect road emissions in the vicinity of construction sites. With this, thanks for your attention. And
Tusen takk, Susanne. Jeg tillater meg å snakke norsk, det greit?
Ja, vi tar det på norsk.
Vi tar det på norsk. Da har vi litt tid til noen spørsmål, hvis det det fra salen. Jeg så det kom noe i chatten. Tar du det, Gunhild? Du kan ta denne mikrofonen.
Nå hører du meg. Hvor kan man finne utslippsresultater for sin kommune? Hva spørsmålet?
Hvis vi snakker for eksempel, da jeg trenger litt hjelp fra Miljødirektoratet. For eksempel hvis vi snakker om klimaregnskap, om klimagasser. Jeg vet at metoder som implementeres i 2022 baserer seg på M-site-resultatet. Det ikke direkte, men baserer seg på resultatet. Hvis vi snakker for eksempel om luftforurensning, hvis du interessert i en kommune, jeg kan sende til deg. Jeg vet ikke hvem spør det, men hvis du interessert i en kommune, jeg kan dele med, ja, det ingen problem. Men vi har en visualisering i NILU websida som vi viser alle resultater av jobbet som vi gjør. Så vi har der visualisering. Men hvis dere interessert i noen spesiell kommune, vi kan dele resultatet. Men det viktig å tenke som det inkluderes bygg og anlegg. Det inkluderer ikke veiprosjekt. Hvis det en kommune med en stor som byområde, jeg tror det blir ikke så dårlig, men hvis det andre kommuner som, ja.
Det kom et supplement her fra Miljødirektoratet.
Ja, jeg trenger hjelp fra Miljødirektoratet.
Ja, takk, Susanne. Ja, det stemmer. Så for klimagass, det ligger på kommunenivå i klimagassstatistikk for kommuner. Så det hvor man kan finne en aggregert tall for klimagass. Med for luftforurensningskomponenter skal vi legge ut alle disse rutene, 250 meter ruter med luftforurensningsdata på dette utslippssystemet som vi har. Så det blir ikke tilgjengelig for oss ned til hva kan si, bygge- og anleggsprosjektnivå, men det aggregert til denne 250 meter ruter som Susanne har henvist til. Så vi legger ut disse data snart i utslippssystemet.
Supert, da vi litt på overtid. Det var ett spørsmål i chatten. Det kort eller et langt diskusjon? Det litt langt. Da tror jeg, Susanne, du har også tilgang til chatten. Nå vi på overtid, ja. Så da tror jeg du kan skrive et svar der i ettertid. Og så da Bedre byluft kom til veis ende for denne gang. Vi sier tusen takk til alle dere som kom, og tusen takk til alle dere som fulgte oss på Teams. Det første gang vi har prøvd en sånn veldig kombinert løsning, og vi tar gjerne mot tilbakemelding på hva som har fungert bra, og hva som ikke har fungert bra. Jeg helt sikker på at det noen nyttige innspill vi kan lære av til neste gang. Jeg vil anta at dette en sånn løsningsform vi fortsetter med. Så da sier vi igjen tusen takk for oppmøtet, og så det lunsj for noen som skal ha lunsj, og ikke helt slutt, fordi Miljødirektoratet skal gi noen kort informasjon for møtet som kommer etterpå.